if we talk about the bone defects for a face, we talk about mostly maxillo and a mandible fracture, which is pretty prominent. There is a bone loss due to cancer or accident or anything. So if we broadly classify, there could be mandible, maxillo and cranial fractures as well. So the challenge is that when the patient suffers a bone loss, that is, the bone is not recoverable, the bone that has broken is completely gone, is fragmented, so it cannot be obtained. So in that case, it is a challenge on how to restore or repair or reconstruct the missing part of, let us say, a jigsaw puzzle. So a few of the challenges which we have encountered over the years are mentioned. Bone loss, so the shape is irregular, thickness is irregular, there could be some infected bone portions, because often the patients who come to the hospital have got themselves treated, I won't say wrongly, but not very properly in the areas nearby. Then when they get the bone reconstructed, there could be a lot of instability issues, infections and all. And a lot of innovation is required on how you fit the implant or the third party component with the bone. It's very critical. Whether the patient who is gone with the repair is able to lead the normal life again, because maybe the fracture that was caused was due to some occupational hazard, and if he goes back, he would face the same issue again, the accidents and everything. So whether that implant is stable for his body or not. Biocompatibility issue is of course there. So our key challenge area is to reconstruct an aesthetic implant or the missing portion which can give the patient back his normal life, which he was before this particular episode occurred. So the proposed solution is very simple. I mean, the surgeon contacts us, he sends us the CT of the fractured skull. We have a team, in-house team of students who use various softwares, ANSYS, CAD, I mean, there are ample number of softwares. They design the missing portion using their 3D models. The approach can be multiple. It can be, depending on the fracture, it can be multiple approaches. You can show them. Multiple approaches. For a skull, it is a bit easy because you can mirror the portion that has not been fractured. Then, the more challenging part, the more engineering part is to optimize the implant that has been designed. We can give the variation in thickness, save on the material, make sure that it's not very heavy. Then of course, we have to fit it using some fixture material. So the innovation part is, whenever that missing implant is fixed on the bone, you can use a normal cement or anything like an adhesive, but there are also screws and plates which you need to optimize. And if you reduce the number of those fixtures, then the weight on the head is reduced. Also to see it will remain safe, so you should build a test rig in your in-house which emulates the same, simulates the same kind of load that he will face outside. So static and dynamic loading both are important. And ultimately, the fact that gives us the benefit is we are only giving a template, a 3D printed template, which is not going to get into the patient. So we do not get into the risk of the material research, material technology, because it is used as a template by the surgeon to just copy it. So this is some of the 3D printed portions that we do in our lab very often. And this is a patient to whom we provided this skull reconstruction solution. She was an adolescent, unfortunate episode that she fell from a rooftop. And fortunately, our process was very successful. And we have been able, luckily, we have published this result in a very prestigious journal. Then again, another craniofacial reconstructed patient. In this case, the patient had his own bone, but during fitment, it got infected. So we provided him the solution. For maxillofacial, it is difficult to reconstruct because our face, by the grace of God, is not symmetrical. It has many technical and small differences. But for a surgeon, if he has to pre-plan his surgery, to pre-plan his corrective surgery, he needs a model to work on. He cannot work it on the computer or the software. So we give him 3D printed models where he can conduct his surgical planning. Now this is something which is very interesting, and some substantial results have been obtained by finding out the various fixture plates that can give better results between the implant and the bone. So there are a lot of shapes, and even the orientation, the location of the fixture plate is so critical. When we do the mechanical analysis of stress strain results, we observe that just minute 2 mm movement of a plate can give such superior results, because we have to find the particular weak point where the bone can actually break when external loading is applied. So we do the simulation, and once the simulation is successful, we now are developing a test bench wherein we will place the skull implant model and loading will be done from different directions. Although there are studies that at 45-degree angle, if you do the dynamic impact, you get the most optimum results for stress testing, like I've shown here. So static and dynamic, both load testing are required, because when you are driving a vehicle, if that guy has got a cranial implant, any collision will hit him very badly, whether it is your windscreen. I mean, of course, if airbags are there, then that's fine. But if it's not there, the side windscreen, the front steering, anything can impact the skull. So impact loading is quite important. So as I told you, the end users, the surgeons are using it. We recommend it for patients who are below poverty line, because rich patients can afford a titanium based implant. We want that this solution should be covered under Ayushman Bharat for serving the society, and it can be used for educational purposes a lot. If you have models like this, the resident doctors can learn a lot during their surgery planning. We have conducted a lot of trials. We have a lot of facility in our lab, but we cannot mass produce it. It's a very low cost solution, rather we do not need much. Technology readiness level, I would say it's 9, because we are already done successfully. We have got quite high impact publications. We can have a technology transfer, we can have a partnership option. Its setup cost could be high, but it has got good dividends. So that's it from my side. Thank you.